our agenda today is we will see two small animations which anybody can create. The whole purpose of this lecture is to make you believe that you can also do this on your own. The first demo which I am going to show you is a small robot. Before that, let's see the abstract of the talk. Modeling can be really fun. Engineering models can be physical, conceptual, mathematical, and digital. When used properly, they can help in teaching, learning, and also research. Games are the starting point. We should encourage our students to play games, animated games on computers, and we should also encourage them to formulate them. It does not require lot of special skill to do this. You can do this on simple spreadsheet, that is MS Excel. I am going to demonstrate to you some small simple simulations. What you see here is a small robot. I have named it as Janardhan. You can see that there are 4 controls: left arm, left leg, and right leg. I will just change the values at some places. For example, here now I have put 0, and you can see the change. The right arm has come down. I make this 0. The right leg has come down. I make this 1. The left arm has gone up. It doesn't require lot of programming knowledge to do this. Anybody who learns formatting, conditional formatting on spreadsheet can do this on his own. Now let's take a different version of this. Once you have prepared a basic robot, you can attach a control to it. Just see how the control behaves. When I shift the control from left to right and right to left, the values in the background keep on changing, and the same activities which we had done earlier in the earlier demo take place repeatedly as per the control. Now the purpose of showing this to you is that though you are students of maybe social science, education, and you might be thinking that we do not know much of computer science, it doesn't require. Even a housewife uses spreadsheet today for keeping her accounts. With little bit extra effort, you can learn what is known as conditional programming. You can see the note at the end. It says nothing beyond conditional programming is used here. So you learn a little bit of conditional programming, and you can practically animate anything what you can think of. Now let us see a slightly different example. Now the title of this example is Tendulkar Scores. Now here you see a animated innings of Mr. Tendulkar. How does Mr. Tendulkar score? When a ball is bowled, either the ball is legal or not legal. If it is legal, then he can score from 0 to 6. If it is illegal, then he gets a score, but that goes to the team. These rules have been intelligently put into spreadsheet formulae, and little bit of conditional programming is added, and we have added a control to this thing. Just watch how when I move the control, repeated instances of the same innings are created. For example, now you have 1, 2, 3, 4, 5, 6, 7 rows. That means in the 8th ball, Mr. Tendulkar is out. If I change it a little bit, now I have a different version of. So you can see I can create many innings of Mr. Tendulkar. So it is like creating a process. In social science or in management, what is most important is processes. For example, admission to the college is a process. A student comes, he does something, his certificates are checked. So various processes can be simulated. When we take observations for research, you get 4, 5, 10 instances happening all over the city, let us say for admissions. But that much data is not enough for research. So you can simulate a process and generate more research from it. Of course, you need to learn a little bit of conditional programming and little bit of functions of Excel. Without that you can't do it. But about a 3 months effort or a 4 months effort to learn these basics is really worthwhile. After that you can recreate processes which otherwise you use in research many times, observe, and you can draw lots of conclusions. So essentially I would like to conclude saying that if simulation, you can create more instances than which you really observe in life, and those additional instances will help you into getting to the bottom of the problem. I hope you believe that this is almost anybody can do. Spreadsheet you always use. Conditional formatting you need to learn a little bit. With this whole thing can help you a lot in very complicated research where processes are not very simple, but they can be simulated on the computers. So far we have seen the application of simulation and animation to research, where basically processes can be handled. Here is an entirely different type of application which you can use. Spreadsheets have lot more capabilities than you really think. Curve fitting is one operation which every researcher has to do sometime or the other. The traditional approach to curve fitting was take data, do lot of statistical calculations, and then arrive at the correct fit that is to be used in the applications. With advancement of spreadsheet, views have become more prominent. Now it is possible to start with scatter plots, create a view, and then simply use add trend line tool to get the curves which are generally fit to the situation. Now here is an example. This is a bivariate analysis. You can see two arrays of data x and y on the screen. So one researcher is interested in finding out y as a function of x. What he has to do, he has to follow those steps which are given on the add trend line is a fantastic toolbox. You can see step 1 is select the two arrays of data. Having selected the data, any one who uses spreadsheet knows how to create a scatter diagram. It simply requires go to insert, then you see lots of charts. After that you need to select scatter diagram as the appropriate chart. Once you see the scatter diagram, you can just see now. I will right click one of the points. When you right click the point, you can see that an add trend line tool appears in the box. This is our friend. Add trend line tool does a visual fit onto the curve, which avoids lot of pre-statistical calculation. Once you have the trend line selected, you have provisions to say you want the value of r square, you want the value of equation. Once you check those boxes, you will see the equations written on the curve as you see in the graph which is shown to you. There are two selections, one is linear, the other is exponential. With both selections, you have an equation, along with that you have an r squared value appearing. See, the beauty of the process is that I have not done any statistical calculations to begin with. I simply took the data, selected the columns, and drew or inserted a scatter diagram. I right click the data to get the diagram as it is seen on the screen. while creating those curves through a right click of the data point, I had also selected r squared and the equation. So now you can see both the curves, a straight line fit and an exponential fit, have an equation and r square written on that. To do this, traditional statistics would have taken hours, whereas because of this multimedia facility which is available with spreadsheet, you are able to do it in minutes. Now you just compare the values of r square. The one which has got better r square is a better fit. In this case, you can see that r square is 0.9989 in case of exponential, whereas r square is 0.4527 in case of linear. So it clearly tells the researcher that exponential is a better fit. Now don't you agree that any social scientist, any the students of education who does not know lot of statistics but still he has access to this tool can get these curves fit with no time. And this is what is the tremendous advantage you have when you use such tools. These tools put visualization first and then they calculate all statistics in the background, removing all the effort otherwise you have to put. I hope you have understood putting visualization first and getting the curve fit done saves lot of efforts, and you don't have to understand lot of statistics to do this. Lot of calculation is avoided. So even a student of social science, agriculture, biology should be able to use these tools and get lot of curve fitting done. So we have seen two components. First component was a simulation, second component was a curve fitting. Put together, lot of research work can be done quite easily by a little bit of effort in learning spreadsheets and their capabilities. We will end with this discourse. Thank you.